All right, here's an easy one for us to do. It says if 3 or more parallel lines cut off congruent segments on one transversal, so that means these two are the same, then it's going to be the following. Then they cut off congruent segments on every transversal. Which means if I know that these two segments are the same, that means these two segments are going to have to be the same also. So here's what the type of stuff that you will see. Something like this example. They tell you that DG, I don't think that's what I wanted to say, DH, excuse me, make sure I get the right one in here. DH is parallel to CG, which is parallel to BF, which is parallel to AE. Those are all the same. And I noticed right away that this segment, they're all the same to each other. Well, if that's the case, that means I automatically can assume that those are all the same. So they're all 2.5. That's because of our theorem up above. Think of it like an egg slicer or a vegetable slicer that does even slices. It will always be, no matter what angle you slice or you put the vegetable in or egg in, it will always slice it evenly. It's kind of that idea. Now, they say, what's the length of segment EH? Well, that's all of those together. So EH is just going to be 3 times 2.5, which is 7.5. All right, here's the one that's on the final. Okay? I want everyone to know this will be there. On the final, because they tell you that these are parallelograms, and now you're going to have to know about opposite sides being parallel, and you're still going to have to use your properties of triangles. So with this one, I automatically mark my opposite pairs of sides parallel. And then I start using the properties that I know, okay? Well, the first thing you need to remember is that your opposite pairs of angles are congruent. We haven't talked a lot about those. Opposite angles are congruent. So that means I know the measure of angle 1 is 115 degrees. Now, if that's the case, we could solve for missing angles after that, right? But let's make it easier on ourselves as possible to do this. I'm looking for the measure of angle 2 and the measure of angle 3. I would look for 3 first, because if I move this over, these are my parallel lines, and this becomes my transversal. And do you guys see the Z shape? Z shapes are forming what type of angles? Alternate interior angles. So I know these two are congruent to each other. So I know the measure of angle 3 is 50 degrees because if parallel lines, alternate interior angles are congruent, right? And then I have to look for the measure of angle 2. Well, I know that's 50, so I plug it in here. I can use the fact that the angles of a triangle add up to 180. Notice that doesn't go away. I still can use that. So the measure of angle 2 is going to be the following. 180 minus 115 plus 50. So 180 minus 165 is equal to 15 degrees. So those are all 3 of your angles. Now let's use the same stuff to our advantage once again, because they said all of these are parallelograms. So I'm going to use the fact that these two sides are parallel and these two sides are parallel, and I'm going to use that to help me find the missing angles. It should hopefully help us get there. Well, 1 and 3, if you notice, are alternate interior angles, so they're going to be the same size. So whatever one we can solve for first, we'll solve for the other one real easily. But actually, the easiest one to solve for is 2. You can see a linear pair of angles. So I find the measure of angle 2, because they're a linear pair, I'm going to go 180 minus 75. Well, that's 105 degrees. So that's angle 2. Now, it actually isn't going to help us solve for the other ones, but do I have pairs of vertical angles yet? Right. I can use this angle and this angle are congruent. They're both 75. So when that's the case, I can easily find the measure of angle 3 now. I can go 180 minus, what's 50 plus 75? It should be 125. So 180 minus 125 is going to equal 55 degrees. All right, so now let's look at the measure of angle 1. The measure of angle 1, because they're alternate interior angles with 3, is also 55 degrees. Love it, love it, love it. Okay, love it. I also think that the next one should be just as easy. But again, you notice I just start marking in everything I know and it just kind of fills it all in. I love that part. So here's my opposite pairs of sides. They're parallel. I can start finding angles I know. What's the easiest angle to solve for first? Angle 2. I totally agree with you. The measure of angle 2 is 72 degrees. Vertical angles. Excellent. How about angle 3 now? Yeah, the measure of angle 3 works because they're a linear pair. You can go this way also. 180 minus 72, 68 degrees. Love it, love it, love it. It's just such a easy way of solving for these. Now, how in the world am I going to solve for angle 1 or angle 4? It's really kind of your choice. But I think the easiest way to solve for angle 1 is using a linear pair. I would probably use the fact that those two angles are congruent. So then I can use the 42 plus the 72 plus 47 to solve for the one that's missing. So the measure of angle 1 is going to be 180 minus 72 plus 47. So I go 180 minus, what is that going to be? 119. That's going to make this one be 60. Make sure I got this right. 47 plus 72 should be 119. That should be 61 degrees. All right, excellent. Let's do another one together. Let's find the measure of angle 4. Now on this, don't let it overly complicate you. I'm going to use stuff to my advantage. I'm going to use the fact I have alternate interior angles. I'm going to use the fact we already solved that one to be 108. Now I can easily solve for the measure of angle 4 because I know the three angles add up to 180. So I'm going to go 180 minus the other two added together, which is 108 plus 40, so that's 148. That equals 32 degrees. All right, you guys did a great job following along. This was a long lesson, but I know you guys will do wonderful. If you sit there and look at your notes and make sure you really apply your theorems, you'll do a great job.